Hello everybody, welcome back to this part where we're gonna take, we're gonna fix these tails so they rotate in the right direction. So in order to do that, we need, I'm gonna make some debug meshes, so it's gonna be easier to explain what I'm thinking about. So first off, I'm gonna make HDRP lit mesh, and I'm gonna set set color to this one. Gonna represent the tangent for the snake. You will definitely understand later what I'm doing. So we're gonna have this as actually we can have a capsule, it doesn't really matter. We're gonna change to the default checker because it's easier to see, and also we're gonna, so what order do we need to do this? Okay, so we actually, I'm gonna plug it in, but what I'm gonna make, this blue dot gonna represent the forward direction on each snake, and also we're gonna do set size, so it's gonna be easier to see what's going on. The size should be, I don't know why it's not visible. 2 maybe. Okay, it's there, just really small. We can do 3, and we're gonna move it a little bit. So, and well, this one, if we're just gonna have it as a velocity, we can just take the velocity and we normalize, normalize, we take get position, and if we add these together, and we do set position like this, now the blue dot should be in front, 1 unit in front of each snake. And also we're gonna have less snakes. Let's do 10 at the moment. And we're gonna do set here. We're gonna make custom attribute. And this is gonna be a vector free. This is really important to remember. And even later when you access it in the update, because otherwise things can bug out. So here we're gonna have a back. So this back vector gonna be behind the snake. So in order to do this, well, we need some more space, definitely. So we do set custom attribute here. We're gonna do vector free again and do the back. So this back gonna be pretty easy. So it's gonna be velocity. Well, get velocity gonna be normalized, and we're gonna have it negate, and put it in like this. So let's see here, we have something going on here. This we should do, I forgot to do this last part, but here it's going to be center force, so we have it nice and tidy. All right, so this is now the back direction, and we have it saved here in the update. So now we have this one, and if we make a copy of this one, and we're gonna make this one staying behind, so we're gonna have a black one, and here we're gonna change, so get custom attribute, we're gonna make it a vector free, and we're gonna have the back. So if we do, instead of having velocity here, you take the position and get adding with a back vector. And if we now plug this one, we should have a back vector as well. So we're doing this because if I could just take so the idea here is that eventually when the snake turns, we want this, let's say the snake went in this direction. Then we really like the way the tail is, right? So if we take this one, we need to calculate the old position. So let's say this. So let's say the snake went in this direction, right? So in order to calculate this, we need to calculate the old position each frame. And we're gonna lerp between this position and between these two. So we're gonna have a lerp here. So the tail is gonna lerp towards this direction. So what I'm trying to say is there will be a direction here. There will be let's see, we have the backwards direction and we have the forward direction. So this represents the direction to the old position where the snake was before. And if you normalize it, so if this is the old position, right, we need to lerp it towards the backward all the time. So that makes the rotation of the tail works as you saw before. So that's why I made these dots to visualize it. So what we're going to make now, so the back direction is the black dot, right? So let's go on with this. So we're going to have this follow position, right? That I was talking about. The vector we don't see here yet. So when we do get custom get attribute current, okay, so we need to get custom. So what's happening here, so you see that we fetching the back and we are also setting the back. So we're actually picking the old value from the last frame and put it to the new one. So that means that we can have the old position, right? So in order to make it to direction on the snake itself, we need to subtract the position of the snake. So when we have this, we need to normalize it. So this is the same thinking process as when you needed, as I showed you in the last part, when you added forces towards the center, right? So this is the same thinking. So when we have these two, we need to, so if this is the back direction and this is the old back direction, we need to lerp towards this position, right? So we just add an lerp, and if we add this lerp here, and then we add this one and we make a tiny lerp value, it will always lerp to the back direction, because if we had one in float here, it would take the second input fully, and of course 0 is the old one here, right? So if we do 0.01, it will always lerp a little bit to this vector. But because there are so many frames per second, this is going to be a lot. Well, a lot or a lot, but it's going to represent good. So of course, maybe we should change this to delta time in some way, but it's going to work good in our case. If you find problems with a quick rotation, you can always mix with the time, delta time. So the last thing we need to do is to add get, okay, add and get position, because what we want to have is we want to update to the correct place. So I've been thinking, let's see, there's something not okay. So we need to just plug this one directly into, not adding position, because we already have it. So if, let's say, we change this value to 0.001, really slow, and save it. Now you can see that the black dot is lerping towards the back. So now it's turning, it's following. So let's see, I want another one. Let's take this one. I'm going to show you. So what's happening here is that there is a difference here. So this angle, we're going to use the dot product to get this angle. So it's going to go from 0, and we're going to have it eventually we're going to have all this. So let's do we're going to have all this all this value here, so we can have -1 and 1. So we can use this information to rotate into the shader. So this is really nice. Now we have two vectors that we can measure to get the dot value. So in order to do this, we're gonna do so here, first off, we make a note. This is the follow position, the black dot. Well, actually, not the black dot, but yeah, it's the updated black dot. Sorry, exactly. This is follow position is the black dot. So we have this one here. So now we need to create a rotate value that we're going to use later on down here and plug it into rotate here. Because as you can see, all the tails, we want to be able to rotate them accordingly to the black dot like this. So let's do that. So we need to, I'm gonna think, we need get custom. We need to fetch the back direction that we made. And we also gonna get the position. So what we do now, we subtract the back position with the we subtract the position of the back with the position of the particle, and by doing that we get the direction, and also we need the blue dot that represent the forward direction. So we know that the forward is the velocity, and we normalize this one, and so in order to have it going, so I'm gonna make a new here to make it more easy to understand. So we have the x, how do you say, the x value here, right? And also we have the blue forward direction, that's Z, and we also have the upwards, that's I, and the black dot is located on the XZ plane. And what we want to do, we want to calculate the dot value on the X axis. So what we need to do is to use the cross product with Z direction and I direction to create the X direction. We know that Z is the velocity forward and the I is always upwards, so therefore we can calculate the X direction. And then we can have all the range here from -1 up to 1. So if we go back and we make a cross product, so we actually have, so you can think about the I upwards, and then we just do the dot product. So if we just, let's see here, so we need to, in here, initialize particle, we also need to add a custom attribute that's going to be rotate. And we need to spell it correct, rotate. And we're going to keep it as a float. And here we're going to set rotate, well, set custom attribute. And it's going to be a float, and we're going to have rotate like that. So we're just going to have, this is what we made so far. So when we have the dot product, so this is the black dot backwards, and this is the red right axis. So now we have the dot product and set into the rotate. So now we actually saved it, so we can actually just, in the shader, we just take custom attribute, and we're gonna read rotate. We just plug it into the rotate. So here, okay, so you see here, the rotate is -1 and up to 1, right? So if we just plug it in, it's gonna be almost correctly. So you see, they are kind of turning. They are just inverse in the turning, and that's because when we calculate the x-axis, well, it depends on how we set it up in the shader graph, but when you do the cross product, you can use the upwards, I upwards, or you use the, so if you look in the, up here, you see the I is pointed up, and the X is on the right side. But if you do the cross product with the I downwards, the X will pop in the other side. And we're going to change that because then the tail going to turn in the right direction for us. So if we go back to the set rotate and we go here, and we're going to cross product. Instead of having the upwards, we're going to do the downwards direction. And now you will see that the tail is pointing towards the old position. There is actually ways to do this more accurate, but it's gonna be so complicated, so I'm just gonna skip it. But this is gonna look good enough eventually when we add all the other details. So that's nice. So we're gonna make this to do some nodes. We're gonna rotate. All right. So if you just want to see what's happened, set position here. If you want to pause and look it through, and here the noise force, and here we have the center force, and we lerp it, and we lerp with how far away it is. We have the follow position. That's a black dot that we made. And the back direction, that's where the black dots tries to be with this lerp value. And we just add the position here, just only for us to visualize with this node here. Because actually, yeah, because here we need to subtract it. In the rotate, we need to subtract the position again, because we only want the vector. So when we have the back vector and we have the wanted back vector, well, let's see. Sorry. So we have the back vector, the black dot, and then we created the X axis and we do the dot product. And then we get the rotate value that we put into the shader. So that's nice. So now we're starting to have the things that we want. So I'm gonna break the tutorial here and keep going in the next tutorial. Thank you so much.